Hi friends, welcome to the session on Poisson and Laplace equation. Right. So in this session we will see why do we need Poisson and Laplace equation and derivation of Poisson and Laplace equation and where we can use these two equations. Right. So first we know that electrostatic is governed by two important laws. One is Coulomb's law and second one is Gauss law. Fine. But these two laws are having their own constraints, right? So we cannot use Coulomb's law if we don't know the location of the charge, because F is directly proportional to Q1 Q2 by R squared. So R is the distance between the two charge. So if we don't know the location, we cannot have R, right? So in that case, Coulomb's law fails. Moreover, the amount of charge is also not known in real time in particular region, right? So these two conditions these two constraints make Coulomb's law is not to be useful at every place, right? So because we see this location of charge, this amount of charge, right? So these two are main constraints when we use Coulomb's law to find electric field. Whereas Gauss law requires charge distribution, right? We know we have to use Gaussian surface which is symmetry with respect to charge distribution, but it is very difficult to get charge distribution in real-time scenario, right, except a few conditions. So Gauss law is also not useful in every application, right? When these two constraints are there, we have to go for Poisson and Laplace equation to find the electric field, right? So let us see how we are going to derive the equation now. Fine. Okay. Let us start with Gauss law. That is the starting point. So we know that Gauss law is given by right. Gauss law is given by delta D is equal to rho V. We know D is equal to epsilon E. So substitute D is equal to epsilon E. It will become like this. And we know that for a inhomogeneous medium, E is equal to minus del V. We know the relationship between E and V because E is equal to minus del V. So that will become rho V, right? So if the medium is homogeneous, for homogeneous medium, right, we can bring epsilon right hand side and we can make del dot del V, right? So that is equal to minus rho V by epsilon. That means what? If the medium is homogeneous, everywhere the parameter will be having this epsilon is uniform. So we can take it as a constant and take outside. That's the condition. So delta del V is equal to minus rho V. So we can simply multiply this. So del squared V is equal to minus rho V by epsilon. Right? So this is what Poisson's equation. Okay? Right. So this equation can be used if we know volume charge distribution. Clear? So if we make rho v 0, that is in free space, we know that in free space rho v is equal to 0 because there is no charge in the free space. So if there is no charge, there is no volume charge density. So what happens to the equation? The equation becomes del squared v is equal to 0. So this equation is known as Laplace equation. Right? So this is the derivation for both Laplace and Poisson's equation. So where we can use this equation, these two equations can be used to find V, find potential, provided we know boundary condition in the region, right? So for example, boundary conditions of a region, right, where see in for example the region between the parallel plate capacitor, right? So with some boundary conditions we can apply potential, right? So in parallel plate capacitor we know the boundary condition. From there we can find V. From V we can find electric field, that is equal to minus del V, right? So this is what about the Poisson's and Laplace equation. So what is the conclusion I want to make here is Gauss law and Coulomb's law have certain constraints, and in order to overcome that, when or where we cannot apply Coulomb's law and Gauss law to find the electric field, we have to go for Poisson and Laplace equation. Moreover, these are all the two equations, and moreover the main thing about the Poisson and Laplace equation is they are working with boundary conditions and scalar quantity called potential. So it is easy to work also, right? So that's all about this session. If you are having any doubt, please ask me in comment section. I will clarify all your doubts. Thank you.